Hi, and welcome to Allen High School's AP IB Chemistry review of some of the things we learned in pre-AP Chemistry. We're working on naming right now, and in particular we are working on acids, which are a little bit tricky. And a student came up with part of a phrase here many years ago to help us out, and then the class and I tried to tack on a little bit of an ending for the last type of acid. And I think you'll understand this, or hopefully you'll remember it from a couple of years ago, depending on when you took 10th grade chemistry. Now, the focal point of the name of an acid is the anion name, because the cation of an acid, the positive ion, is always H+. So as long as it has the word acid as its last name, and you must include that, that communicates that the cation is an H+ ion. And so now the rest of the name has to tell me what the anion is. Now in our polyatomics, remember there's a pattern of decreasing number of oxygens from per-ate to ate to ite to hypoite. So as you go down that list, you lose an oxygen. So when we learned our polyatomic ions, you memorized your eights. You go up an oxygen for the per-ate and then down for the other two. Okay? So that's a quick review of how we did our polyatomic ions, which hopefully you've been reviewing already. Now, to get the acid name, there's just 3 rules that you have to memorize. The first rule is that the ate ending gets changed to an ic. Notice we didn't drop the per. The per stayed the same. We're not changing prefixes. We're only changing suffixes. Sorry. And ate goes to ic. Now, the other one, second rule, is that ite goes to us. We keep the hypo. Ite goes to us. So that's our second rule. And then our final rule is I'd. I'd, this is the time we are actually adding a prefix. Remember I said we didn't change prefixes, but we might add one. This is the only time you add the prefix hydro and then change I'd to ic. So the phrase is I ate something icky, ate goes to ic, all night, ite, I was nauseous, because I took a ride on a hydroic plane. Okay, so hopefully that helps. So let's see some examples of going from formulas to names and then names to formulas. Now let's write the anion. Remember the cation's always H+, so the anion in this case is F-. The name of a single element anion is fluoride. If it ends in IDE, even if it's cyanide, if it ends in IDE, you're going to add the word hydro. Remember, fluorine has the flu, FLU, and instead of "ide," we're going to put "ic," hydrofluoric, but that's not quite enough. We have to add the word acid. Okay, now let's do the next one. Our polyatomic ion is PO3 -3. Okay, if you forget it's -3, there's 3 H pluses, so it must have been -3. So if those are +3, that must be -3. This is the phosphite, not phosphate. Phosphate's PO4, 3-. This is phosphite. Ite goes to us. Now with sulfur and phosphorus, you have to kind of throw in that UR and OR. So it's phosphorus, not phosphorus acid, but phosphorus acid. If you say it out loud, it should make sense. Okay, let's do the next one. We have IO4-. Iodate is IO3-, so this must be per-iodate. 8 goes to ic, we keep the per, so this is per-iodic. 8 goes to ic, and then we add the word acid to tell us that the cation is the H+. Okay? So that's how you go from formula to name. Now let's go from name to formula. So we have perbromic. Remember, ic came from 8. So this must have been perbromate. If you don't know your polyatomic ions, we've got some problems. So that's perbromate is BrO4 minus. Now to get the acid formula, we add an H plus to neutralize all the negatives. So in this case we had 3 negatives, and so we added 3 H pluses. Now in this case we have 1 negative, so we only want to add 1 H plus. So it's HbRO4. Okay. Acetic acid, it came from 8. So this is acetate. There's a couple of ways we write acetate. C2H3O2 minus. It needs 1 H plus. And when we do that, these H's are not acidic. They don't come off. So we want to distinguish this one, and we would put it on the front. HC2H3O2. Now, another way of writing it makes it clear what the structure is. And I think you'll see this when we do our organic naming and structure activity, which is part of this unit. And so we would have CH3COOH. So those are the 2 common ways that you'll see acetic acid written. Okay. Now, we're going to do an in-class activity on organic molecules. We're going to be building models and having you learn the names rather than having me just tell you these names, because that is something that is fairly new, most of it. You know just a little teeny bit of it. And then in the next set of videos, I will start net ionic equations. So until then, this is signing off.